Hi students, good afternoon. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Samdom for Peace. In this video session, we shall discuss loops. So this is the Codio exercise, and we're gonna go ahead and open this in PyCharm. As usual, we shall do the exercises in both environments, in Codio and in PyCharm. Now, what are loops? Loops are a loop is an iterator, and then you ask me what is an iterator. So iteration is an act of doing something over and over again. You want to repeat a process. You want to do something repeatedly until you get a result. So when we talk of iteration, whether in computer science or in mathematics or in education, we are looking at doing something over and over and over again until you get a result. So kind of like practice makes perfect. You're doing something over and over and over again until you get a result. So that is what we mean by iteration. And then one of the ways of doing that is by loops. Okay, so a good example, you can like in game design, for instance. In game design, you can program it in a way that, okay, while the score is still probably less than 20, then this person will be so thin, or this person will be so thin, or this person will be the winner, or this score will be this, or while this while the duration of the game is so this in this segment, then this should happen. You see that a lot in a program like game design. While this is this, then do this. So we're gonna come here. We're gonna go ahead and let's go ahead and open or let's go ahead and create a new project. Let's create a new project, and I'm gonna come here and I'll just say loops, or let's call it iterations, and then we will now because loops are just one type of iterations, and I want to open it in current window, the project. And I'm gonna come here and I will right click, new file, new Python file, and I'm gonna call this loops. So in Python, let me start with JavaScript. JavaScript is a scripting language. Python is a scripting language. Python is also a programming language, as you already know. In JavaScript, for instance, you have about 4 loops, at least 4 loops. You have the for loop. You have, when I say at least 4 loops, I mean the number 4, F-O-U-R. Okay, so you have the for loop, you have the for in loop, you have the while loop, and you have the do while loop. Now, some other languages have several types of loops. Some have more than 4 types of loops. JavaScript has at least 4. Python has only 2. As of the time of this recording, as of the time and date of this recording, Python has 2 types. of loops, a for loop and a while loop. So just the easiest example is this, okay? With a for loop, okay, so, well, let's start with a while loop. With a while loop, a good example is this. While something is this, while you state the condition, while you write while, then you state the condition. Then you now perform the action. And after performing the action, you increment, okay? While you state the condition, then perform the action, then increment. Sometimes you will need to initialize it. This is called initialization. You initialize it. Sometimes you need to do that. Sometimes you don't need to do that, depending on what you want to achieve. So, for loop, sometimes you initialize it like they did here. You set a variable first to a value. You assign a value to a variable, initialization. And then for this in this, okay, for this in range, you see they put range here, okay? Those are built-in functions. For this in range, this to this. Then perform this action also. So here, they didn't put any more increment. They didn't, because already when they put range and put 0 to 10, this is already incrementing from this to this, from this to this. And by default, it increments by 1. So bring it to real life application. While you are still living on earth, thank God. Day 1, then you loop. Day 1, you're still living, thank God. Day 2, so you see the looping. Day 2, it comes back here, the loop. Then is the condition still being met? Then perform this action. Day 3, this is like day 3, is the condition still being met? Perform this action. Then it gets back to this line of code. You see, it does it line by line. While this condition is still met, perform this action, then loop. Okay, day 1, then you go back here. The condition is still met. You're still living, thank God. Day 2, because it increments by 1. This is incrementing by 1. Day 2, you're still alive, thank God. Day 3, you're still alive, thank God. Day 4, you're still alive, thank God. Day 5, you're still alive, thank God. So that is, and day 6, you're still alive, thank God. Day 7, you're still alive, thank God. And it goes on and on. That is while loop. For loop, for you in this world, from day 1 to, to you keep on, provided you're still living. And usually we put increment. For you in this world, from day 1, what do? Thank God. Then you go back again. For you, because it starts with 0, it starts from 0 up to 10. This one is up to 10. But this is just a numerical value anyway. So for you in this world, from day 1 up to all the days you will live on earth, you write it here. How many days would you like to write? Okay, for you in this world, from day 1 you were born to all the days you will live on earth, thank God. So it starts with that day 1, and then it comes back here, then it goes to day 2, it comes back, it performs the action, you thank God, you come back here. Day 3, you perform the action, you thank God, you come back here. Day 4, you perform the action up until the last day on earth. That is for loop. Okay, so You might ask me, which one should I use? And, when do I use it? So, for this video, we're gonna try to use both of them for the same question that we are doing, so that you can get, you get the view from both ways. We are going to try for the majority of the questions we shall do in this video. We shall write it both in for loop and in while loop. So, and we will execute it. It will give us the same result. As we move ahead in this video, you will decide which one that you prefer. I already know the one I prefer anyway. But you decide. It depends on the work you're asked to do. If you're working on a project, it just depends on the specifications of the project and the requirements of the project and what you want the project, like the requirements of the project. Because whichever work you get as a computer programmer or designer or in any capacity working in technology, whereby you might need to write Python scripts, the main thing your organization wants is let it work. Okay, let it work. So whatever program you're writing, you make sure it works. People, most probably, they're not gonna check, hey, did you use a for loop or did you use a while loop? So whichever one that can get the job done, that you're comfortable using, that is it. And we will try in this video to do most of the questions using both for loop and while loop, and then you now choose whichever one you want to do. So as usual, we will write this both in Codio. We will do it in Codio and also in PyCharm. So I'm gonna come here and make a comment. Loops. At least you've had the idea of what this means. So later you can read this here. We run this code next. So later you can read all these on your own. So question 1, they'll pass in a value. Write a program that outputs all values from 0 up to and including n. You pass in a value n. I'm just gonna copy this here and I'll come here, comment this, and Control V, paste it. Kind of want to paste it here. Okay, so you see it. You pass in a value n. Write a program that outputs all values from 0 up to n. So if you pass in 5 as n, it should write 0, 1, 2, 3, 4, 5, including n. It should include n. Okay, it should include n. So if you pass in 3, it should output 0, 1, 2, and 3. Let's call this question 1. Okay, and let's go ahead and get a notepad, so we can be saving our code. Once the code runs, we'll just save the codes. We'll save all the codes here. All right. Let's do this first with a while loop. We're gonna do this let's start with a while loop, and this will be here. With a while loop, we kind of want the count. So let's say we want the count. So let's initialize the count. So we say count is 0. In Python, once you assign a value to a variable, you have defined that variable already. So we now say while with the while loop, you have to have the while the count is less than or equal to n. Now it will hear n is in red, okay, because I've not defined n, unresolved reference. As you can see here, they had the n from the command line. So let's come here and define our n. N is integer, because they want it to be an integer. So int input, we've done all this, okay. We'll say enter an integer, or just enter a number, it doesn't matter because it will convert it to an integer anyway. But enter a number, and let's have this in a new line. How about it? Let's have it in a new line. So now y count is less than or equal to n. We put a colon. That is the way you write the loop. You just like we did in conditional statement. We've done the video on in conditional statements. Please, that reminds me, prior to viewing this video, please make sure you view all these videos in order. Make sure you view them in order. So while this is less than or equal to this, while the count, from the count, okay, from 0, because it says from 0 up to n, and it wants you to include n. So we now say, and we initialized the count is the variable. So y count, we first of all we set it to 0, okay, then while 0, which is the count, we just use count, it's good to use variables. So y count is less than or equal to n, up to and including n, and including n, and including n. Then you put the colon, okay. Now what do you want it to do? What is the condition? What is the action to perform? This is the condition here. This is the command statement. This is the condition. And then while you want it to do this, what action do you want it to take? Print count. Okay. And then after that, you now loop. Okay, you loop it. Count is equal to count plus 1. So I don't like using, I don't usually like using this, but you can use it. I'm just gonna comment it, but you can use it if you like it this way. That's fine. The way I like it is I say count plus equal 1. Okay. So this means that you start with 0, then you increment by 1. After 0, then 1. 1 is still less than n. If 1 is still less than n, you print it. You print out 1. Okay. So let's go ahead and run this, and I'm going to explain it. So I'm gonna come here, run loops. So enter a number. Let's say we enter 3. Okay, as you can see, it is 0, 1, 2, 3. That is what they want. 0, 1, 2, 3. So let me explain what this did. Let me explain what it did. We initialized this. We initialized this. We called it count. You know, if it's good you use a variable, because we need to print out the values of that variable. So we assigned the 0 to the variable. That means, and that variable is count. Assigning a value to a variable in Python means that you have defined that variable right away. Okay, you don't need to come and define it like as integer or float. No, you've already assigned it to a value. That means you can use it. In Python, that means you can go ahead and use it without having to define it again as integer, you know, like you have in other languages. Now, while the count is less than or equal to n is the user input. in this case is 3. You see it's in green color. It's in green color. While this count is still less than or equal to, because they want us to include n. Okay, print that count out, print it out. So it starts with 0. We print out 0. Then we need to increment it, okay, by 1. So 0 plus 1, because this, what it means is you do, the count is 0. So what this means is 0 plus 1. That is what it means. Count plus 1. So 0 plus 1. And put it as the new value in the count. 0 plus 1 is 1. Then it goes back here, the looping, that's the loop. Okay, it goes back. Is 1 still less than or equal to 3? Yes. Print out 1. It prints it out. Then it still loops. 1 plus 1 gives you 2. It puts 2 as the new value of the variable. Okay, then you come back again here. Is 2 still less than or equal to 3? Yes. Then print 2. It prints it out, 2. Then it comes and loops again. 2 plus 1, 3. Then it comes back here again. Is 3 less than or equal to 3? Of course, 3 is equal to 3. And the answer is yes. Then print 3. It prints it. Then it comes back to this loop. 3 plus 1 is 4. Then it comes back here again. Is 4 less than or equal to 3? No. And it stops. So that's why you have it like this. Now, if you didn't put this equal to, and you run it with 3, if you put in 3, it will only give you 0, 1, 2. You see? So that's it. But the question here, it says, and including n. So we have to put it equal to. So you run it, and it gives you that. 3 gives you 0, 1, 2, 3. See that? And let's see here. Did they ask us to use a particular? I don't think they asked us to use a particular, whether while loop or for loop. But we're going to use both anyway. We'll use both. It doesn't matter. So we're going to come here and we'll copy this. I'm going to copy this. And I'm going to paste it here. And we'll just go ahead right away, copy this, paste it in this notepad. Okay, paste it in the notepad. And of course, if you check this, it works. You check it, it works good. Thank God it works. Now, let's do this with for loop. So we'll do this for loop. For loop, you still ask the user to input. You still request for user input. With for loop, and I'm going to explain this, and then you now see which one you prefer. So we'll say for n in range from 0 to n plus 1. Then you put your colon. What should happen after that? Print n. Print n. So let's look at this, and well, let's run it first. You see just 2 lines of code, right? Now, with while loop, how many lines of code? 1, 2, 3, 4. With while loop, you had 4 lines of code. With while loop, 1, 2, because you first of all used count equal to 0. Now, with for loop, see what I just did. Let's go ahead and run this. Let's run it. I'm going to enter 3. And you see, it gives me the same thing. Okay. So which one do you prefer now? Which one do you prefer? Let me explain for loop. Let me explain it. With for loop, you must not, like you see, I used n here. I could have used count. I could have used count if I wanted to. Okay, and then I'll say print count. It will still work. But you see, let me run it again. I put 3. It still works. Now, you see now I didn't, and then you asked me the question, why did you not initialize count? And you asked a good question. Okay, because let me put this side by side. In while loop, I had to initialize count in order to define it. That's in while loop. In for loop, I did not. I just used it. You can use anything, any name you want here, you can use it. Any name at all. Okay, you can use any name at all. You can use provided it's not a, it's not a predefined name. You can use Samuel. You can use Samuel if you want to, without having to assign it to anything or initialize it. Without having to, you can use anything. Okay, but I'm gonna use something that is relevant to this. That is relevant to this question. So I'm gonna use count. Now, so look at what this does. This is the actual thing. And you can see for in. In JavaScript you have for loop and then you have for in loop. In Python we call it for loop, but actually you can say it. You can see it is for in loop. But we just call it for loops. But you see we are using for this in this. So what this does is that this 0, if I have, let me explain this. If I have, let's comment it. If I have range, let's say we have C, D, E. Okay, usually it takes 3 arguments. This is what we call arguments. Later we'll go into details on this. So C is the initial, point to start from, or the starting point. Starting point. Starting point okay, that is your C. I have to comment this out, that's why. And then D is up to, okay, the end point, but it's not included. So we say end point, but not included. Not included. Okay, D is not usual. It's not included. It's up to. Okay, it's up to D. Actually, that's what it means. It actually means. It actually means up to D. So it's not included. And then E is your increment. E is the increment. So with Python 3, they used range. Python 2 used, I think, X range. But Python 3 used range. So it makes it easy. Makes it much easier. Usually it takes 3 arguments. C is the begin with that. So actually, this count we are beginning with 0. Okay, so we are not coming now to initialize it. It's not, we don't need to anymore, like we did in the while loop. With the for loop, it means this range is a function that takes in 3 arguments. It's a function that is a built-in function in Python. It takes in 3 arguments. The first being the initial point. Okay, start with count equal to 0 and up to n. Now our n is 3. So you now see why I put n plus 1, because if I don't put n plus 1, then it will give me 0, 1, 2. But if I want to include that 3, I have to include n plus 1, so which is 4. So it will now give me 0, 1, 2, 3, 4. You see why? Because if you run this now, it will give you 0, 1, 2. So that's why I have to put n plus 1. Do you see that now? Why I have to put it? Okay? So start from 0 up to 4, but don't include 4. That is what it means. The D is the endpoint, which is not included. It means up to D. And then E is the increment. So you might ask me, where is the increment here? If you don't see the third argument, it means 1. So if I come here and I just put 1, no problem. It increments by 1. As you can see here in the while loop, it's incrementing by 1. It increments by 1. So the 1 is still here. It's the third argument. If you don't see it, if I don't put it, it still means that, I mean, I can put it. This will still work anyway. This will still work. If you want to put it, you put it. Okay? If you want to put it, you put it. Especially if it does not increment by 1. If it increments by some other number, then you will need to add it. Add the argument. However, if you know it's going to increment by 1 anyway, I mean, I prefer writing less code. I mean, if you want to put it, that's fine. But I'll just prefer it this way if you want to. Because you already know it will increment by 1 anyway. However, some professors are kind of picky. And some people are detailed. They want every detail. So you can go ahead and put the increment if you want to. So if we also copy this here, if we copy this and paste here and paste it, for loop, and still run it, it still works. You see that it works. So it's the same output. It just depends which one you prefer. So which one do you prefer? Okay, we are done with question 1. Does it make sense? Does it make sense? So we'll just come here and we'll paste this. That's for loop. All right, folks. The next one is question 2. So like I said, you just choose what you prefer. Just choose which one you prefer. We'll pass you a value n. You should output every positive value from n down to and including 0. So this case is no longer 0, 1, 2, 3. They want it to be 3, 2, 1, 0. That's what they want in this question. So we come here, question 2. I'll paste this. So let's write the while loop. Let's write the while loop. This here will initialize it. So we say count equal to 0. Then while because they want us to start from 3. Okay, 3, 2. If we put 3, then it should be 3, 2, 1, 0. If we put 7, it should be 7, 6, 5, 4, 3, 2, 1, 0. So here, remember in this case here, it was 0 beginning first. Okay, while 0, the count is less than or equal to n. So, but in this case, should be n greater than or equal to the count. Okay. Print n this time around, because that's what we want. We don't want to print count like we did here. Here we said print count, but in this case we print n. And then the increment now will be n equal to n minus 1. Like I said, I don't like using this. So what I will just do is n minus equal 1. You see that n minus equal 1. So it says me what is n. So we can just put it, copy, or we can just type it, it doesn't matter. So we define n. So you can do this, you can do this, it doesn't matter. Okay, because here it wants us to, that's why we're not printing count, we're printing n. Okay, you can also write this while count is less than or equal to n. You can also write it that way, but now you print n rather than printing count because you want it to be 3210 instead. So let's go ahead and run it. Let's run this. If I put in 3, so you see that 3210. Let's go ahead and write the for loop. We can just put a space. You know, another way you can print a new line, you can just put print like this. I mean, I know we've talked about doing it this way, new line. That's one way. We talked about it in previous video. Just a line to demarcate the result. But you can also do print and you just leave it like this. You can do that. So it tells you just print a new line. So we want to now write the for loop. So you will see codes 3210, you see a space, you see a line, an empty line, and then you also see 3210. You know that this one is the while loop. The first one will be the while loop, and the second one is the for loop. So our for loop, we will say for count in range. Okay, you make sure you put that. Now we want our range. We want to start with n. Remember, the first argument is the starting point. Start with n, and then we want to go down. We want to include 0. So if you put in 0 here, it will not include 0. Okay, it will not include 0. So we have to put in negative. After 0, you have -1, so that it will include 0. And then the increment here, you know, we need that increment because the increment here in this case will not be 1. If we don't put any other argument, Python will take this as 1, that the increment is 1. So it will keep adding, you know, and it will keep adding, and the ending point is never gonna be -1. And guess what? You know what will happen to your code? Well, don't worry, we'll test it. We'll test it and you'll see. So we will put -1, and the increment in this case will be -1, just like that. And you put the colon, and then print count. Print count. If you still want to use count, you know, use print count, you can do it this way. So if we run this, we put 3. So as you can see here, oh yeah, we don't want to use this count. Let's do this separately. Let's just do this separately. Let's do this separately, okay? So what I'm gonna do here is I'm going to do this. I'll come to code and I will just comment with line code. Actually, we've run this, so this is not a problem. We've run this. So what I'll do here now is to comment this. I'll comment code, comment with line code, and then I'll come here. And I will come here. I'll just go to code again, comment with line code, and it removes it. So you run this. If you run it, you put 3, and it still gives you the same thing. See that? 3210. All right. Now, let's say you didn't put the third argument, which, like I said, If you don't put it, that increment is +1. And then you run this, and you run this. See? It says process with exit code, but Python, you can keep adding 3 plus 1, 4, plus 1, 5, plus 1, 6, plus 1, 7. There's no way you can get to -1. You see that? So the increment is -1. Okay, you run it, now it works. Isn't it wonderful to have choices? Like, I like choices. I like varieties, I like varieties, several ways to do stuff. Isn't it nice that you have several ways to do stuff? So I'll just come here, I'll copy this, and paste it here. When you have several ways to do stuff, that's fine. But sometimes some people, they like, when they learn it one way, they don't want to learn another way. They don't want to learn another way. But if you're a teacher, you will have to learn many ways to do a particular problem, so that if your students do not understand one way, then you can teach them the other way and they will understand. And that is the thing about mathematics. We have so many ways to explain it in mathematics. Excuse me, to do questions in math still gives you the same answers. And that's another thing I like about computer science, programming. You have several ways to still write it and it works. This might not even be the only way. You can even figure out, by testing yours, you can even figure out something that works. So I like varieties. I like choices. Several ways of doing things. Especially if you're a teacher, you need to know more than one way of doing it. So let's go ahead and I'm gonna comment this, and we just cut this. So we can go to question 3. Actually, this is question 2. So just copy the thing, question 2, and cut it. Come here and I paste this. And if you want this, let me know. Okay, if you want this, let me know. All right, question 3. I hope you're understanding this. I hope you're understanding it. Next one, this is a tricky challenge for you. We will pass in a value n. N can be positive or negative. If n is positive, then output all values from n down to, and excluding 0, so not including. And then if n is negative, then output every value from n up to and excluding 0. So that's fine. Let's write it. Copy. Comment this. Paste. I just come here and comment this code. Comment with line code. All right. Let's do this with while loop. We'll do it with both. While loop. We'll say here, here we have if this, then output this. If n is positive, then output this. If n is negative, then if n is positive, they want you to start from n and go down to 0, just like what we just did. However, do not include 0. So we will not be using equal to. We use greater than or equal to. We will not use that. We will only use greater than. Okay? And then if n is negative, then output every value from n up to. They want us to count up. From that n, maybe let's say it's -3. Then they want you to count -3, -2, -1, but do not include 0. Okay. So let's initialize this count to be 0. Then we say if we have to, here we have to use a conditional statement as well as loop. So we say if first, if n, so we need to define n actually. N is integer, input, enter an integer. And we need it in a new line. So if n is greater than 0, make sure you put your colon like we did in conditional statements. And with, first of all, if n is positive, which means if n is greater than 0, then we put in our while loop. While n is greater than count. Okay? While n is greater than count. So if n is greater than 0, it's just the positive first. It's the positive. Now our count is 0, we initialized it. If you want, you can put while n is greater than 0 if you want to. However, we've been using variable count and initializing it to 0. So let's keep on with that. So while n is greater than count, because it's n is a positive integer, while it's greater than 0, we will not put greater than or equal to, because here it says excluding 0. So what do you want while it is doing that? Okay, print n. Then increment. Okay, n. Well, in this case, we are going down. Okay, so it's just what we wrote before, 3, 2, 1, but we will not put 0. So minus equal 1. Then we have another condition, elif. Now you see the indentation. I hope you're looking at the indentation. And we're not using else. We're using elif. Okay. Elif, else if n less than 0. Okay, you put your colon. Make sure, as you can see, the indentation is very important. Importante. Es importante. Okay. Es muy importante. Now, elif n less than or equal to 0, while n is less than, now this is for negative integers, while n is less than count. Okay. What do you want to do? Print, go ahead and print n. Print n. Then you now increment up. Increment it up. Plus equal 1. Because they want it up. From n up to if it is negative. But if it is positive, it will be from n down to. See that? Alright. Let's go ahead and run this. We will test it for both cases. If we have 3, it is 3, 2, 1. Okay. We run it again. Let's test it for negative. If we have -3, it will be -3, -2, -1. That is what we want. Okie dokie. Okay. So negative, then put it from up. Okay. So you keep adding 1. But if it's positive, then from that integer down. So you keep subtracting 1. All right. So this works. Thank God it works. Now, let's do this with 4 loops. With 4 loop. Let's do it with 4 loop. So with 4 loop, we of course write our conditional statement. If n is greater than 0, then for count in range. For count in range from n up to 0. Now, we are not including 0, so we can now here put up to 0. Okay? But we want it that we want to be subtracting 1, so we must put that increment. We put the increment -1 as the third argument because it's from n up to 0, not including 0. Okay, and we want it to be decreasing by 1. We want to count down 3, 2, 1. Okay, that is for positive. Now n greater than 0 here means positive integers. Yeah, so we just print n. Else if elif n less than 0. Okay, then for count in range from n to 0. And here, you know, if you want, you can just leave it this way because we already know we are counting up and the increment is 1. But some people might get confused, you know, so let me go ahead, put 1 as the increment. However, like I said, even if you don't put 1 as the increment, you know, anytime you don't put a third argument, it defaults to 1 as the increment. Is that third argument, which is the increment, defaults to 1. But let me go ahead and put it. Okay, print n, and that is it for the for loop. So let's test it for the for loop. We'll come here. I'm going to comment all this out. Comment this, and then I run this. So if we test it with 3, 3, 3, 3. Oops, I said print n. Oh no, print count. So print count. Okay, print count. As you can see here, I said here print n. Yeah, that's for this. Yeah, but this here is print the count. You know, I can, if I want to print n, I can also put n here. If I want to, maybe I should do that so you don't get confused. But let's test this. This is 3, 2, 1. Okay. If you want, you can also put this here, n. You can. If you don't want to use count, you can also put that. And then you come here, you print count. You can put anything you want. Yeah. But you know why I like using another value is some people usually get confused with this, but let me leave it as n. So print n, so you don't get confused here, you know, print n. So if we do that, we test it for 3, it is 3, 2, 1. Good. We test it for -3, it is -3, -2, -1. Good. So I will uncomment all this, comment it again. So, and we can paste anyone at all. We can paste anyone. Let's paste the for loop. For some reason, I prefer for loops. I don't know. I like it, but you know, it just your, like I said, it's your preference. Whatever you want to do. We check this. Yup. Thank God it works. 6, 5, 4, 3, 2, 1. All right, next one. You can read this. You can read this yourself. Later on, read this. You can read all this. Read it yourself. Read it. Okay, we have another challenge. We have more challenges. Okay. Times table. Let's go ahead, folks. Let's clear this. And let's go ahead and cut out this. Cut. And come here and paste it. Okay, question 3. Question 4. Question 4. All right, what they want. We will provide you with a number n. Output the times table for that number from 1 to 12. So if we pass in 6, you should output 6, 12, 18, 24, 66, 72. Okay? I'm going to copy this here. Paste it here and let's comment this. Comment. Okay, let's do this in both while loop and for loops. Let's start with while loop. Let's start with the challenging stuff, right? Well, for some reason I feel that for loops are easier. So I feel that for loops are easier. Both are easy anyway, but I feel that for loops are much more easier. But so let's start with the one, that needs more lines of codes. Let's start with the one that needs more lines of codes, right? We are going to this is multiplication, and they want it to be from 1 to 12. Whatever we pass in, they want it, like if we pass in like 3, they want 1 times 3 is what? 2 times 3, 3 times 3, 4 times 3, 5 times 3, 6 times 3, up to 12 times 3. That's what they want. And they want the output. So we will say, let's initialize this. Let's initialize it. Let's call this value. I know the previous one we said count. We'll call this value and let's call it 1. Why we will not put 0 is because, first of all, before we do this, let's define the user input. Int integer input, enter an integer. Please enter an integer. Whatever you do in America, you say please, right? Please enter an integer. Let's put it on a new line. Okay. Whatever you're doing with students, right? You've got to say please. Okay, so I'll do this value. Let's set it to be 1. Why? Why not 0? Because some people will say, why not 0? If you're like me, I like asking questions a lot. I want to know, why is this so? Why? The other one I put count to be 0. Now I put count to be 1. Okay, we don't need, they said here from 1 to 12. They didn't say 0 to 12. Okay, so is the value that we'll be multiplying by n. Whatever the user puts it at n, the user will put in something as n. Let's say the user puts in 3 as n. Then we will say 1 times 3. We won't start with 0, no. We'll say 1 times 3. Then we will increment this value. Okay, we'll increment it by 1 again. 1 plus 1, 2. Then we do 2 times 3. We get 6. Then we increment it again. Okay, 2 plus 1, 3. Then we do 3 times 3. We get 9. Then we increment it again. Okay, up to 12. So that's why. So we initialize that variable to be 1. Then we'll now write while the value, because it's from 1 to 12. So from value less than or equal to 12. While it is less than or equal to 12, what do you want to do? Let's have product, because this is, let's define another value. Let's define another variable. Let us define another variable. So product will be the value times n. the user integer, whatever the user puts in. Okay. Then we can go ahead and print that product, print product. Okay. Then after that, we will increment, because each time we print, we have to find, okay, 1. Let's say the user puts in 6. So if we put in 6, then while 6 is less than or equal to 12, is 6 less than or equal to 12? Yes. So product is 1 times 6. So print 6. It prints 6. Then after that, will it go and stop? No, because if you stop it here, it will only print 6. Because I really want you to understand this. Oh, you see, if you stop it here, it keeps printing 6. Because while 6, as you see, this is still running. It's still running. You see, it's still running. If you put this code in, you see, it's still running. Still running, you see that. So I'm going to just stop it. Stop it. Because, and you see, process finished, exit code, -1. You only run it right if it says exit code 0. So this is timeout process. If you write a code like this, then it will not work. It's using up system resources, and it's not still yielding anything. So you can even break it anyway if you will come to break, you know. Like after writing this and you see that such is this, you can go ahead and break it until you fix the code. Until you fix the code. Anyway, yeah, if this is running, you put in maybe 7, it prints out only 7. So because it prints it out and it breaks it. Otherwise it will keep running. So you've learned another function, break. Is an inbuilt function. When you when you write a code, because sometimes we can't have a runtime. So this not enough. We don't want that. And if you put it in Codio, probably, let's try to put it in Codio. Let's try to put it, because sometimes you need to test all this in your time. You can test all this and see. Please wait while we check the answer. So it will keep on doing it. It will keep doing it. And it's using the system resources. Can you imagine that? Sometimes it might even slow down other processes in your machine just because of a code that is not working. You see, terminated by timeout. That's okay. All right, folks. So I want you to really understand how this process, you know, we don't just want to write code. You need to know which one is this. So after we print the product, then we now increment it. Okay. We now say value plus equal 1 plus equal 1. We now increment it. Okay. So it will now be 1 plus 1, 2. So 2 is the less than or equal to 12, yes. Then you now do 2 times whatever integer you put in. 2 times 6, 12. It prints out 12. Then it increments it 2 plus 1, 3. Is 3 less, while 3 is less than or equal to 12? Yes. Then print out 3 times 6. You do 3 times 6 is 18. You print out 18, you know. So you do it that way. Okay, so if we put in 3, you see that 3, 6, 9, 3 times 1 is 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12, 3 times 5, 15, up to 3 times 12, 36. See that? It works. Okay, and this is the answer anyway here. That's the answer. But I want to explain something to you. You know, we just come here, we put in value plus equal 1. But I want to explain something to you because that is one of the objectives of this video. I will teach you some other things as we move ahead. When somebody sees this, you know, some people might be, okay, what does this mean? So let us do something nice, better here. Let's format it well. So we could write this. This is something I like with Python 3. We could just do braces. Okay, this times this equal to this. Okay, dot format. We want the value times the value n and then the product. Okay, let's run this and see. 3, if I put in 3. So as you can see here, 1 times 3, 3, 2 times 3, 6, 3 times 3, 9. So kind of makes it easier here, don't you think so? Is like, don't you think here is much neater than just writing the output 3, 6, 9, 12, 15? I mean, I think so. Now, if you look at this here, some people will say, I don't like this kind of, like, it's not well arranged, well arranged. We can do something on that. We'll come in here. We can have this. We put this. Let's do padding. Let's do padding 2 here. We can also put more space here. And let's do padding 2 here. Let's do padding 2 here. Although it's only 3, we can actually leave it like that, just 1 padding. And then let's do padding 3 here. We can do padding 3 here. And we can extend this space also, so it kind of makes it look nice. Okay, let's run this. Put in 3. Now it kind of looks better, right? Looks much better. So this is like padding 2, and then we have this like this, and padding 3 here, and we put more space here. Maybe we need to close out this space, and we can just close down some of these spaces, and it looks better, looks neater here, right? Looks much neater. Okay, so and you might ask me, like I said, this is a feature with Python 3. Is in the library. We will see it later on, but it's a nice feature of Python 3. I can even show it to you right now. Anyway, I can show it to you. Let's get on my website. SamuelShukwuemeka.com. Technology, and then resources, Python. So this is a feature with Python 3 that is nice. How did I find this now? Format using braces. Curly, some people call it curly braces. Let's see here. What's new in Python 3? Okay, Python 3.6. With curly braces. I should think where I found this now. I think I found it in let's look at the squares and cubes. Squares and cubes. Input and output. I think that should be this. I know I'm gonna find it, okay? Using curly braces. Let's do this. Input output. Yeah, fancier output formatting. That's this. Yeah, 7.1. fancier and fancier output formatting, and that is this here. See that? So you can read it. You can read it up. You can read it up on your own. All right. Another thing we can do, just from what I saw here, if we don't want to define products, we could actually say, if you don't want to, we could comment this out, and we'll just come here and we put value times n, As you can see here, right here, formatting it, dot format x, then x times x is the squares, x times x times x are the cubes. See, these are nice features that you could use. So we could still do that here. If we don't want to define products, we'll just put value times n. When we run it, it gives us the same thing. Okay. All right. Now let's do the let's write it with the for loop. We just say for range. With for loop, we actually don't need to. For value, we don't need to initialize the value at all. Like, this is completely different. Like, I'm going to comment this out now to let you know. Like, with for loop, we don't even need to initialize this. We just say for value in range, although it's good to define your variables, but it's not required in some cases. You can just write it. So for range, we want to start with 1 up to 30. Now I will not put 12, because if I put 12 here, the endpoint will not be 12. The endpoint will be 11, because the increment is +1 by default. So I'll say for value in range 1 up to 13, which means stop at 12. We can just print this right away. Just this. So you have only 2 lines of code. Only 2 lines of code. Only 2 lines of code. And this will work. So 3, put it, gives us that. You can also do this like this if you want to. If you want to start with n and do value. 2 times 1, 2, 2 times 2, 4. In this case, like 3 times 1, 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12. You just change it here. When you put dot format, you put n first. So with n, it's gonna give me 3, 3, 3, 3, 3, 3, 3, 3, 3. So I really don't need padding. I can come here, pad it 2 spaces, and then I can pad the results 3 spaces. Then I click run, put in 3, and as you can see, 3 times 1, 3, 3 times 2, 6, 3 times 3, 9. See that? Okay. So that's a way to write it, and it looks nice. Looks nice. All right. We're gonna do question 5. We're done with question 4. I hope you are really understanding this. Let's go ahead and cut this out. We are done with question 4. Come here, paste it, Control V. All right, question 5. Oh, yeah, we'll check this now. Okay, works. Factorial notation. Factorial is in mathematics, permutation and combination. We use that. We use the factorial notation in permutations and combinations. That is combinatorics. Factorial notation is this. Okay, if you have 4 factorial, call this question 5. Question 5. Write the write the program that computes the factorial of a number. The factorial of a number. In this case, it's an integer, right? Yeah, of an integer. All right. Using loops. We want to just use loops because there are some other ways you can do this, which I'm going to show you. So look at what factorials mean. If you have 4 factorial, this is, you know, in English, that is 4 exclamation mark, right? Mathematics, we say it is 4 factorial. Okay, so this is 4 times 3 times 2 times 1. That is what it is. Okay, some textbooks will write it like this: 4 factorial to be 1 times 2 times 3 times 4. Up to 4 and including 4. If you have 7 factorials, 7 factorial, it means 1 times 2 times 3 times 4 times 5 times 6 times 7. Okay, that's the formula. Or some textbooks will write it as 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, I did this in my videos on discrete, finite math and discrete math. That's where you learn this: finite math and discrete math. Combinatorics. That's this, combinatorics, where you learn those, and then the notes are here. All right. So if you have n factorial, that is n times n minus 1 times n minus 2 times n minus 3 times n minus 4 up to times, you know, up to times 1. That's what it means, and that is what they define here in the code. Up to times 1. All right. Well, let's write this. We'll do this with loops: while loop, for loop, and we'll also do it with a library, math library, which is the easiest. But let's start with this, okay? So, excuse me. While loop. We say value to be 1. Now, we know, note, 0 factorial, because some people will say, what about 0 factorial? Because you have 2 factorial is 2 times 1. 3 factorial, 3 times 2 times 1. So 0 factorial we say is 1. Note that. And also note 1 factorial is 1. 1 factorial is 1. I'm gonna call this factorial notation. All right. With the while loop, we initialize this to be 1, value to be 1. Then we say factor, because look at what let's talk about this. So we want to compute, like, let's say 3 factorial is 3 times 2 times 1, or you can say 1 times 2 times 3. So we want to, it's easier if we do it 1 times 2 times 3. It's easier that way. Okay, so we will, there will be a value first, n, because what you want to calculate as the factorial. So let's define the variable input. Please enter an integer. Okay, let's make this in a new line. So we need to have an increment. One, if it's like, okay, if it's like 3, it will be 1 times 2 times 3. If it's 4, it will be 1 times 2 times 3 times 4. Now let me say this. Usually you would write the conditional statement. If the n is 0, then factorial should be 1. So we'll have something that will be factorial. Then we have a value. We have that value that will be incrementing. So we need a value that will be incrementing. Let's call it value. And in this case, 1. It has to increment. Okay, then we have the factorial result. Let's have the factorial result as 1. Okay, if it's 0 factorial, it must be 1. The factorial will be 1. If it is 1 factorial, the factorial result. Let's call it factorial result. When I call it factorial result. So it's in camel casing. Now, we'll now say while the value is less than or equal to n. No, not equal to n. It has to be just less than n, because we need like 1. We can have, if it's 3 factorial is 1 times 2 times 3. Okay, we need that value. Will increment it. We will be incrementing it. So while value is less than or equal to n, we are going to multiply it by that value anyway. I will multiply it by the factorial. So we say y value is less than n. Okay, what do you do? Then go ahead and find factorial result, multiply equal to value, then increment it. Now this probably will test it anyway, and then you print factorial result. We keep multiplying the values. And then increment it, multiply it by the factorial result. So y value, let's put less than or equal to, okay, 1. Y value less than or equal to n. Yeah, because like 4 factorial is 1 times 2 times 3 times 4. So we start with 1, then multiply equal to. So this is what I mean here. Factorial result equal to factorial result times value times the value. Okay, or you can say value times the factorial result. That's fine. Value times the factorial result, which is the same thing. So we're beginning that our factorial result is 1. Please let me write it first, like factorial result times value. So while 1 is less than or equal to, let's say we are looking for 3 factorial. Okay, is 1 less than or equal to 3? Yes. So factorial result is 1, equal to 1 times 1. Okay, that gives us 1. Then we want to print the final answer. I know we come here. I'm gonna show you something anyway. If I come here and put print, okay, then we'll see 1. We'll see 1. Okay, it will print 1. Then it will now increment 1. 1 plus 1, 2. Is 2 less than or equal to 3? Yes. Then we now do, this is 1. 1 times 2, which is 2. It prints 2. Okay. Then it comes to increments it 3. 2 plus 1, 3. Is 3 less than or equal to 3? Yes. Yeah, so please, we'll put this 3 less than or equal to 3, yes. Then it comes here, it says 2 times 3 is 6. Okay, so let's look at this first and see. Let's run it. Run it. We put 3. So as you can see it here, 1, 2, 6. Okay, which is great. It gives us what we want. Is 1, while 1 less than or equal to 3. Yes, 1 is less than or equal to 3. Then factorial result, which is 1, will be 1 times 1. Okay, I can add out this comment. So it starts with value 1. So is 1 less than or equal to 3? Is 1 less than or equal to 3? And the answer is yes. Then factorial result would be factorial result already is here is 1. 1 times 1, and that gives us 1. Okay, then you now print 1. You print 1. Then you now increment it. You increment it. Increment 1 plus 1. Increment the value will be 1 plus 1, which is 2. Remember I said you can, this is another way to write it like this. Value is equal to value plus 1. So all these comments kind of guides you what I'm doing. At least you understand what I'm saying. So, okay, then 1 plus 1 is 2. Then it comes back here, goes back to the loop. Is 2 less than or equal to 3? Yes. Okay, it goes back to the loop. Then you now have the factorial result is 1 times 2, and that is 2. Then you print 2. You now say here is 2 less than or equal to 3. While loops are something else, honestly. They are something else. And then you now is yes. Then factorial result here, factorial result would be 1 times 2, because that's, you know, the value is 2 here. The value is 2. 1 times 2, and that gives you what? 2. So you print 2. You print 2. And that's the 2 you see here, 2. Then you increment it. You increment it. Increment. So the value would be 1 plus 2. Because you say 1 and add it to the value. Value is equal to value plus 1. Or you can say 2 plus 1, that's fine. Okay? Which is 3. Then is 3 less than or equal to 3? Yes. Okay, and you keep on doing that, and this gives you 6. Now, 3 factorial is 6. Okay, as you can see here, 1, 2, 6. All right, guess what now? So the factorial, 3 factorial is 6. And if we do 4 factorial, it should give us 24. 4 factorial. And that's 24, the last part. Okay. So I'm going to come here, and I'll copy all this. I copy it, come here, paste it, check it. Okay, program output, we'll put in 4, expected output is 24, but it's giving us 24. So we only need this 24. They don't want us to have the results of the loop. Okay, Codio doesn't want us to have the results of the loop. They don't want us to do that, and that's okay. If they don't want that, that's okay. So what we're gonna do here, folks, is we will come here and we will in this same here, we will not indent because this printing this result is part of the loop. So we'll come here and I'm going to comment this out. And here, without indentation, we'll now say print factorial result. Okay, instead of printing the factorial result to be part of the loop, we just say print factorial result. So when we run this now, we run it 4 factorial because they want us that, and you see 24. See that? So usually, let's make it nice. I always like making it this thing. The factorial of the number you entered. So you entered, the number you entered is equal to this number. And I'm going to come here and put dot format. The number you entered is n, and the answer is factorial result. So just making it nice, you know, making it look nice. So we do this here. We enter this 4. The factorial of 4 is 24. See that? So that's much better. Okay. So what we'll do here is we'll come here and we'll just say print factorial result. And I'm going to come here and just comment this. That's all. Comment this. And this should work. Yay. Thank God it worked. Good. And this code also, with this code, you don't even need, that's one thing I like about these loops. You don't even need, like if you check it for 0, you put in 0, the factorial of 0 is 1. Yeah, you don't need to write a conditional statement again. Like, you know, there are, we will talk about other ways you can write factorial notation. It's not just this. So, but in this case, you don't need to put in those conditions that if n is 0, then factorial should be this, because with the way we wrote our code, it solves that. And if you test it with 1, factorial of 1 is 1. Okay, thank God this works. Let's go ahead and copy all this. We will write this with for loop, okay? And I will show you with the library. So I'm gonna come here and I'll paste it. Question 5. Okay. Let's do this same thing with for loop. So I'm going to come here, for loop. Now, with for loop, we just need the factorial result. We're going to put factorial result to be 1. And then we now say for value, in range from n up to 0. It's much better for me. Like if you want, this case is in the while loop we did from 1 up to n. Okay, in the while loop, in this while loop we did from 1 to n, like 1 times 2 times 3 times 4. That's the one we did in while loop. For loop, let's do it this way, from n to 1. You see, this from n to 1. Let me put this colon. 4 times 3 times 2 times 1. So we'll illustrated in for loop is this one, and this one is illustrated in while loop. And you can play with this, okay? You play with it, you can write your own, make sure it works. So for value in that range, okay, from 4, let's say 4 factorial. So from 4 to up to 0, but not including 0. and we decrement it. Okay, increment by -1 or decrement by 1. We say increment by -1 or decrement by 1. So from 4 to 1, okay, what do you want us to do? Factorial result times equal to, okay, with factorial times the value, okay, but I just say times equal to value. For some reason I like doing it that way, you know. And then we can just go ahead and print factorial result. So let's run this and see. You see how many lines of code? You see, with for loop, you see, few lines of code. Okay, if we put 4 factorial, okay, from 4, it starts with 4. 4 is the value. Okay, so this is the way this works. Let me show you the way this works. Okay, for value in range, this. So this means that the value is n. Value is n. Okay, in this case it's 4. Okay, say 4. Say 4. Our factorial result is 1. So we now do here, because this means factorial. This is the same thing as saying factorial result. Factorial result equal to factorial result times value. That is the same thing as saying that. So our factorial result in this case is equal to, the factorial result is 1 times 4, right? And then we print 4. We print 4. Then remember, it's from n to 1. So from 4 to 1. So the next one will be the value. The value is equal to 3. Okay. Remember, our factorial result 1 times 4 equal to 4. So in this case now, the new factorial result here, factorial result will be 4 times 3 times the value, and that is 12. So you print 12, print 12, print 12. Okay, then next value is 2. Next value is 2. So factorial result will be 12 times 2. Factorial result will be 12 times 2. See that? Because this, the value, the 12 is not the factorial result, then 12 times 2, 24. And that becomes the new factorial result. Then you print 24. See how the loop works. That's how it works. Then the next value, the last value is 1. Value is 1. So factorial result is what? Factorial result is 24 times 1. And that gives us 24. Okay? Then you print 24. And that's the why we have that. 4, 12, 24, 24. That's how we have that. Now, if you just want just the single output, okay, we can just say what we have here. I'm just gonna copy it, and we write it here. Okay, and when we run this and test it again, this gives us the whole thing. Then the factorial of 4 is 24. It gives us each process because we use this kind of code. Okay. All right. I'm gonna copy this. Actually, this is copy this here, and just because I've already pasted. Question 5. So we already pasted it here. 4, 4. So I'll just do this here, paste, illustrated in for loop, and then I'll come here and this is the for loop. I'll copy it and paste it here for the for loop. It's good to like have all these codes. Now, so if you don't want to do all these anyway, the third way, and this is not the only way. We've done while loop, we've done for loop. Now let's do this with library. So I'm going to just leave only this. We will come here under these loops, then we'll just do import math. Okay, math is the library. Later on we'll discuss library. I think this is the second time we are mentioning libraries so far. So libraries make it easier for you because you know one thing with technology, reusability. Somebody has wrote it, put it in library, so just go to library, the math library, and grab what you have there. So what we'll just say that factorial result, once you put import math, we are importing the library, the math library. We just say factorial result is equal to, just like that, math dot factorial. As you can see, it comes up math dot factorial, and then you just put n. Okay, math dot factorial, and that's it. That's just it for this one. That's it. This is a using library factorial notation, using the math library. And when you run this, you run it for, and it gives you that right away. So you see all these codes we've been doing, we just import math library and we just do that. Yeah. However, you know, you don't when I cut this, we will come to this. I think this second time we're mentioning libraries. Later we will talk more about it. Factorial notation using the math library. Okay. Next question. Squared. So this is question 6, right? That's question 6. Okay. I hope you're learning a lot of things so far. Question 6. Like this. We'll provide you with a value n. You should calculate the sum of each value of n squared from 0 up to and including n. Okay, so up to and including n. So I'm just gonna copy this, put it as comment. Comment this. All right, folks. Let's do this with while loop. At least you've known the basics, you've understood the basics, right? So in this case, they will give us a value. We are going to square it, and we will sum up all the squares. That's the thing. They'll give us a value, then we will square the values. Like if they give us 3, they want us to start from 0 up to and including 3. So they give us 3, they want us to find 0 squared, 1 squared, 2 squared, 3 squared, and then we add all of them up. That's what they want, right? That's what they want. So if they give us 3, they want 3, they have 0, 1, 2, 3. So they want us to do 0 squared, which is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So 0 plus 1 plus 4 plus 9 gives us 14. That is what they want. Okay. Let's first of all ask for the user input. N is equal to integer input. Please enter an integer. A positive integer in this case, actually. Okay. From 0 up to n. So we can be more specific. Please enter a positive integer. Okay. So we will, for while loop, let's initialize it, value to be 0. We will find the value, we will square it, and then we will sum it. Okay. We will square it. Okay, let's have a square 1 and then sum to be 0. Now, I'm not doing, some people ask, why don't you do squared to be 0? Okay, we're not doing it like maybe 0 squared. No, we're not doing it. It's not like that. No. You're doing it as, we used value to be 0 because we'll start with 0. Okay. Now, when we square something, we are looking at, okay, what will be the initialization? We can't square things except if it's 0. If we square anything, it won't give us 0, except if the number is 0. So if we square, because this is like square times something. So this initialization means what value can we put so that it won't affect our result? That's what it means. Like, what value should we put? Should we initialize it as so that it would not affect our result? That is what the initialization is all about. So if we do 1 times anything, because we will square it, and square means 0 times 0, 1 times 1, 2 times 2, 3 times 3. So even if we multiply all those by 1, it won't change anything. But if we multiply all of them by 0, assuming our square is 0, then it messes the whole thing up. Okay. And when we do our sum, if we add 0 to our sum, it doesn't take away anything. So the initialization is, what do you set that initial value as? So that when you use it in your code, it won't affect the code at all. That's what it means. When we do squared, assuming we put 0 here, and when we begin to use it in the code, square is x times x, then it messes it up if we use it. So that is the idea of the initialization. Excuse me. So we write our code while value is less than or equal to n. Excuse me. Square, the value would be value times value. Okay. Value times value. And then if you want us to print, if you want us to be printing this, we can be printing it if you want us to print it. Like, while value is less than or equal to n, you want us to print this, so you kind of say it. Print value. Square is value times value. Print square. Like, we can do this so you see it yourself. Then, we'll have to find all the squares first. We need to find all the squares first before we now find the sum. So after finding the squares of the value, then we increment the value. Increment it, value plus equal 1. Okay. Then after that, we find a sum. Sum will be plus equal square. Plus equal square. Which means, okay, I'm going to put it in comment because some people probably will like it this way. This means sum plus square. So I'll just, because the sum is 0, so 0 plus square, that's what it means. That's what it means. The square is value times value. Sum initialization is 0, so 0 plus square. If we don't initialize this, we can't use it here in the code. So we have to initialize it. That makes it defined. Then we can now use it. Then we can print some. We can print some. So let's run this and see what. Let's run this. Let's put 3. If we put 3, now let me quickly explain this. Let's see what they have in their code anyway. If we put 3, it should give us 14. So that means, and we don't see 14 here. So we'll fix it. Okay, we'll fix it. But let me explain something, folks. Let me explain something. Oh, you know what? I should comment this out. Let me comment this out. Run this again. 3. Okay, there you go, 14. Yeah, 14. I did this, so it did it several times. 14 plus 14, 28. So I had to comment it. All right. 14 is the answer that they want. What we are doing is, I've explained this. We print the value, then you square it. You print the square, then you increment it. You keep on incrementing it. After, you increment it, you find the sum. This is just sum plus square. And then you print the sum. So let's go ahead and comment this out. Comment this out. And we just shift this here. Because they want us to have only 14 as the answer. They want only 14 as the answer. So we'll run this again, put in 3, and that's 14. Good. So you can say the sum of the squares is 14. You can format it the way you like. Okay. Let's proceed because the video is getting long. So let's kind of proceed. Now let's do the for loop. For the for loop, we now need to initialize because we are dealing with several stuff. So square is 1, sum 0. Then we can say for value in range n plus 1. So let me explain this here. We said if you have, usually it accepts 3 arguments. 3 arguments. Okay. It accepts 3 arguments. What we had here. It accepts 3 arguments. In the for loop. Yeah. So CDE. Okay. Let's add some codes here. Okay. If E is not given, the default increment is 1. That is, if E is not given, the default increment is 1. Now, what if only one argument is given? If only one argument is given, then it is D. Then it is taken as D. It is taken as D. It is taken as D. We assume it to be D. If you have only one argument. So why am I saying this? You come here. If you come here, for value in range, and I gave only one argument. Okay, so this is, we just take it as D, not the starting point. Okay, we just take it as up to N. Because remember, if it's just N, then it's up to N. But we want to include N, so N plus 1. So we put N plus 1. So square is equal to value times value, value times value. And then we can just print, we can print square. We can just print square. So we've written this here for the while loop. Let's take it out and we discuss the for loop. I'm gonna come here, and this is actually question 6. Question 6. I'll copy this. I'll come here and paste it. All right. Now let's discuss for loop on this. So I'm going to cut off the while loop. So let's go ahead and run this. Enter the positive integer is 3. And this gives us up to 9. This gives us 9. See that? Just this last one. Now, we could just, as you see here, we just did square. Okay, it just squared it. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. That is what it did. We've not finished the code, so we can just do sum plus equal square plus equal square, and we can print sum. Okay, now this is still part of the code, so if we put this 3, the 14 is still here. Okay, so we can just later put the print sum here. So and if we want, we can remove this print here, so we have only 14. If we run this code, we have only 14, and that's the answer here. Okay, now but let us like make this really nice. If we have this here like we did here, we'll see this and we see 14. We can, I want to show you something. You can make this look nice to differentiate it from 14. As you can see here, 14 is the answer. Like even if I move this to be part of the loop, if I move that to be part of the loop and run this and put 3, it still gives me 14 when it is part of the loop. And if I move it to be actually part of the program and not part of the loop, I still have 14. So let's find a way to do this. We can do this square. I want to teach you something very important now. Square, and you can put and equal to and equal to, so that you have it rather than vertical 0149, you have it horizontal. Let's see. And then you have it horizontal. But then you see this 14 is mixed up. So let's space this out. We just put a space here. And then we put this 3. And there you go. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And then the sum is 14. If you want to do this, you see. Only if you want to see only the squares. So 0 squared 0, 1 squared 1, 2 squared 4, 3 squared 9. Okay, but the way I think I prefer this is, I'm just going to come here. I'll comment this out. I'll comment this. And then I will come and print it well so that it looks nice the way I like it. So I'm going to say this times this, braces, this times this, equal to this, and I format it, dot format. I want it to be value square. I like it that way. So let's see how it works. So I put 3. I say 0 times 0 is 0, 1 times 1, 1, 2 times 2, 4, 3 times 3, 9. And then the final answer is 14. I think I prefer it that way. Okay. We can now say that the sum of the squares is, I put a comma and then I put sum. Okay, the sum of the squares is that. Kind of makes it nicer, you know, make it nice. So the sum of the squares is 14. So it looks better, right? All right, so that is the, let's go ahead and copy this. We copy it, we come here and paste it. That's for loop. And let's do that for here. So the only thing here is they want us to just print sum, and that should work. Oh wow. Let's see here. If you have to expected output 5. Okay, so this is still using this. We'll just comment this, comment that out, because they want just the final answer. There you go. Works good. All right, next one. We will pass in two values, x and y. You should calculate x to the power y and output only the final result. You will probably know that x to the power y exponent can be calculated as x times itself, y times. So we'll pass in two values. So let's write this question 7. Exponent. Comment it, paste it, and then comment it. So we'll say calculate x to the power y. X to the power y. Okay, so we have this here. X is that's an integer, right? They want it to be all integer. Okay, integer input. Please enter a positive integer, because they are doing it with positive integers. Okay, please enter a positive integer, and then I want this on a new line. Or it really doesn't matter in this case. We can leave it as new line. With integers, it doesn't matter. Integers and floats, it doesn't matter. So input here, but with strings, you have to be careful. Remember what we said earlier on. Please enter a positive value. Okay, it mustn't be integer, just positive value. But even if we enter something that is not an integer, this will change it to an integer. It will convert it to an integer. Okay, so we have x and y. So easiest way to write this, folks, easiest way to write this, we have that, let's make the comment that x is known as the base, of course, and y is known as the exponent. I mean, we mustn't use loops to write this. I mean, the function is already there in it's a built-in function in Python. The result, if we have result, is equal to mode, sorry, not mode, power, okay, power x, y. That's the answer. And then print result. So if we do that, enter a positive value, enter the base. You know what? Let's say, please enter the base. Let's stop this. It's running. Let's stop it. Please enter the base. Please enter a positive base. For now, let's deal with positives. Positive base and then positive exponent. Maybe next video we will look at all the cases. But for now, I think they want us to deal with positive base. And the video is getting long, so let's get it wrapped up. Okay, so enter a positive base. Let's say 3 raised to power 2, 3 squared. And the result is 9. You see that? I mean, it has the function already, a built-in function, POW, power, x to the power y. That's what it means here. And I bet you this would work maybe in Codio. I bet you this should work in Codio. Let's see. Oh wow, it worked. Meanwhile, we are supposed to write a loop anyway. But we are supposed to write a loop. Okay, let us write the loop. This is here. This is just here using formula. This is here using formula. So I'm gonna cut this. Oh, I need the whole thing. Question 7, copy. Now let's write a for loop and test it. So here we could have result. We can have, let's initialize it. We need to initialize it, and we can say if y is 0. Okay, we can have that first, that if y is 0, print any base with a 0 exponent gives a result of 1. Okay, any base raised to exponent 0. Any base raised to exponent 0. Any base raised to exponent 0 gives a result of 1. Okay. Else if y is greater than 0, because we are looking at the if the exponent is 0, if the exponent is 0, then the result is 1. If the exponent is positive, which we want, because that's what we want. Okay, if it's positive, which means greater than 0, then for y in range y plus 1 up to y. Okay, that's why we put y plus 1. This would be, that result would be x. Now this is the symbol for exponentiation. Okay, this is the symbol for exponentiation, double asterisk. If you go to libraries and you type in exponentiation, you'll see it. I think it's under operators, right? Operators. Let's see, operators. There's a list. Exponentiation, you see, that's double arrow, and that is the function is the POW. I know I use the function. I use the inbuilt function power. Yeah. Later we'll do functions, and if we do functions, you can easily use it. But for now, this is the what we will use. Okay. The first one I used was just the function, but here I'm now using the for loop. So for y in this range, okay, up to y, I mean in this case including y, okay, because that's including y. That's why I put y plus 1. What do? We find the result and then we just print it. We print the result. Print result. Okay. So let's run it. Positive base 3, positive exponent 2, result is 9. So it worked. Thank God it worked. Okay. Let's go ahead and paste this here. And that is what actually they need in, that's what actually they need in Codio. So I'm gonna change this and put this. Okay, check it. Okay. All right, next one. Fibonacci sequence. Fibonacci sequence. So with the Fibonacci sequence, when you do 0 plus 1, it gives you 1. You do 1 plus 1, it gives you 2. 1 plus 2 gives you 3. 2 plus 3 gives you 5. 5 plus 8 gives you 13. So you get the digit by adding the previous 2 digits. You get the 21 by adding the previous 2. 8 plus 13, 21. So that's a sequence, that's a series of numbers. We should call this what? Let's clear this. We should call this question 8. Fibonacci sequence. I hope you're understanding this, right? Fibonacci sequence. Comprende? Comprenez-vous? Do you understand? Unawataraya? Okay, so you can read this up, okay? You can read it. We'll pass in a value n, write a program that outputs the complete Fibonacci sequence for n iterators. If n is 0, then we expect to get an output of 0. If n is 1, then we expect to get 0, 1, and the rest of them. All right. Let's paste this. Let's write this. So let's start with a while loop. Let's start with a while loop. I've seen Fibonacci sequence in the Python library. So let's use Python library. I'm going to come here. This is still the Python library. Remember, I got it here. I'll come here and I'll type Fibonacci sequence. Okay. Let's see what it brings up. Some people will say Fibonacci. I mean, whichever one. I hope I'm pronouncing it right. Okay. Let's see here which one might be it. Fibonacci sequence. I know I've seen it in the library. I've seen it in the library before. Let's just put Fibonacci and see. I don't know if I pronounced it. Let's see. I hope I spelled it correctly. Yeah. Fibonacci sequence. Okay. Let's do this and see. Okay. Fibonacci numbers. Okay. I think I've seen a code. I've seen a code like that before. So I mean, in the documentation, I've seen a code. Now these are the squares. These are cubes. I've seen a code on that. Okay. See, this is a while loop. This is a while loop right here. So why don't I just copy this, folks? I copy it. You will say, hey, Mr. C wants the easy way out. Why is he copying code from 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 the library? I mean, they gave us, look, let me say this, in your job, you've got to use these libraries. You've got the documentation, you have to always look at it. I'm not saying copy verbatim. We can change stuff anyway. Just in the when you're now writing your documentation or submitting your paper, you now say, okay, I use the library as reference, provided you quote the library. Is not plagiarism, provided you quote it. Okay, so this is the code here. Okay, let's run this and see. Now it's asking us, this is the code AB. They initialize this, you know. Another way you can do this is like this. You can say A equal to 0, B equal to 1. But it makes it easier just saying AB equal to 0, 1. That's the initialized it. Okay. And then the indentation. While, yeah, we need to indent this one. Okay. All right. While B is less than 10, then print B. So let's kind of run this and see. Let's print this out. Let's print this out. Well, print B and equal to, let's see. Well, so we have this 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8. See that with the while loop, this is, if we look at this here, they want us to put n. So let's modify this. Let's go ahead and modify this code. N is integer input. Please enter an integer for which you want the series. Actually, they want it if they put in 1. If they put in 0, it should be 0. If they put in 1, it should be 0, 1. Okay, let's see. So while B is less than n, okay? While B is less than n. Let's run this and see. If we put 1. Oh, wow. This didn't give us anything. All right. What if we put 3? So it gives us 1, 1, 2. Okay, but it didn't give us 0. As you see here, it didn't give us 0. And what if we put 0? If we put 0, it did not. If we put, it didn't give us any output. If we put in 1, it didn't give us any output. Okay, so what we can do here is this. Look, you know, here in this code, they printed B. They printed B. You initialize this, A is 0, B is 1. So while B is less than n, of course, 1 is not less than 1. That's why it did not work in 1. When n is 1 and your B initially is 1, while 1 is less than 1, of course, 1 is not less than 1. So it's not going to work. It won't work that way. You print B and then, yeah, and then A will now be B, B will be A plus B. So let's say, what if we print A? Let's say if we print A and run this. So if we put 0, it didn't work. If we put 1, it still didn't work. Okay. Yeah, because while B is less than N, 1 is not less than 1. So of course it didn't work. So we'll come here, we'll put this here. Okay, we'll put less than or equal to. That should work for, if we put less than or equal to, okay, if we put 0, it didn't work. If we put 1, something should work at least here. Okay, 0 and 1, good. You see that? While B is less than or equal to 1, while B is less than or equal to N, it gave us 0 and 1, just like what they wanted here. If we put 1, 0 and 1. Okay, and we wouldn't, I know they had it like this, B. Of course, if you had printed B, if you put in 1, it will only give you 1 and 1, which is not what they want. So actually, they want us to print A in this case. So maybe Kodio probably thinks, rather than you to copy it from the documentation, you have to modify it yourself. So if we put 1 here is 0 and 1. If we put 2, it should be 0, 1, 1. Okay, 0 plus 1 is 1. If we put 3, at least 0 has to come first, because why? We are printing A, and A initially is 0. If we put 3, let's run it. If we put 3, is 0 plus 1, 1, 1 plus 1, 2. Okay, if we put 4, it will be 0, 1, 1, 2, 3. That's what it would be if we put 4. If we put 4, we put 4, oh, 0, 1, 1, 2. While B is that, if we put 5, so we'll see there's 0, 1, 1, 2, and 3. Okay, this is not what we want. This code is actually not what we want, because if we put 4, because look at this Kodio here. Kodio says if they put 0, they expect just one output. If they put 1, they expect two outputs, 0, 1. If they put we need to do it from 0. Okay, we need to find it from 0. We are printing A, and that is not what Kodio wants. That is not what Kodio wants. Let's see here. Let's copy this and paste this. Check it. Okay, so this is what Kodio wants. If they put it for 8, they want it to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So do you see the difference? Do you see the difference here? Kodio wants it to be executed 9 times if they put it as 8. If they put it as 8. Let me change this to B, so I will want if they can give me another distance. Yeah, so that's not what they want at all. That's not what they want. They want it to be executed with n equal to 8. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 values at least if n is equal to 8. If n is equal to 0, 1 value, 0. If n is equal to 2, 2 values, 0 and 1. If n is equal to 3, 3 values, 0, 1, 1. That is what Kodio wants. Let me explain. Let me show you what they want. This is what they 1. When n is 0, like they are not, this is still Fibonacci series. It is, okay? It is. But they want this to be at least 6 steps. 6 values. 1, 2, 3, 4, 5. It's only 5 values. And when you had it at 4, when we had it at 4, it's only 4 values. When we had it at, if we have it at 7, you see it's only 5 values. They want 8 values. This is still Fibonacci sequence, okay? But the way we wrote it here is while the b is less than or equal to n, which is the b, the value of the b. Kodio is interested in the counts, so we have to use the counter. When n is 0, they want 1 value. Okay, they want 1 value, and that is 0. When n is 1, Kodio wants, this is the way Kodio wants it. When n is 1, they want 2 values, which is 0 and 1. When n is 3, when n is 2, they want 3 values, which is 0, 1, 0 plus 1, 1. Okay? When n is 4, sorry, why am I doing this? When n is 3, they want 4 values, which is 0, 1, 0 plus 1 is 1, 1 plus 1 is 2. Okay? So when n is 4, they want 4 values, which is nice here. Okay, works here, okay? Oh, sorry, when n is 3, they want 4 values. But here, yeah, which works here. 4 values, good. Now, when n is 4, they want 5 values, which is 0, 1, 0 plus 1 is 1, 1 plus 1, 2, 2 plus 1, 3. Okay, when n is 4, they want 5 values. But here is only 4 values. You see the problem? See that? When n is 6, when n is 5, they want 6 values. 6 values, which should give us 0, 1, 0 plus 1, 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5. Okay? When n is 7, when n is 6, they want, this is 6 values, I'm sorry. 6 values. When n is 6, they want 7 values. So do you kind of grasp how Kodio wants it? So this is 0, 1, 0 plus 1, 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8. Okay, right? When n, let's make it up to 8. When n is 7, they want 8 values. And that is 0, 1, 1, 2, 3, 5, 8. Then 5 plus 8, 13. And then when n is 8, they want 9 values, which is 0, 1, 1, 2, 3, 5, 8, 13. 8 plus 13, 21. This is what they want. Yes. All right. And here, when our n is 8, it's not even giving us that. Okay, so it's gonna depend on counting. So it won't depend on like the B, print B. You know, we've been printing, we print B. Okay, so it's not gonna depend on B. All right, let's modify this code. Let's modify it, initialize it, and we'll put another here, another variable, initialize this counter to be 1. Let's initialize the counter to be 1. So while we'll just modify this code. While counter is less than or equal to n, AB will be B, A will now be B, and B will now be A plus B. Okay, that's how the series is formed. You get a term by adding the two previous terms. And then let's print A. Print A. Then we now increase this counter. Counter plus equal 1. We now do the increment. Okay, let's run this and see. When n is 8. Print this, and let's see all this in one line. Okay, if you want to see it all in a vertical line, print it. Okay, so you see here we have what? 1, 2, 3, 4, 5, 6, 7, 8. 8 instead of 9. We don't have the 0. Let's set this counter to be 0. And try this again. Print this. 8. Oh wow! Now it gives us 2134. Okay, we'll do this counter. We'll get it back to 1. We'll write a code, but let's copy this first. I know it's not gonna work anyway, but let's try it. Let's try this. Copy. Come here and paste this. Check it. Okay, let me. I know they need that 0. Okay. 0, yeah, expected output. As you can see here, mine is that the 0 is missing. The rest of the values are okay, just that the 0 is missing. All right. I'm gonna write this as for loop. Let's write this as for loop because it will be easier that way. It's gonna be easier to write this as for loop, much easier. Let's see. And I will just comment this out. I'll comment it out. So let's initialize this AB to be 0, 1. For value in range from 0, we need 0. Okay, we need that 0 to n plus 1 up to n. Okay, for values starting point 0 up to n plus 1. Of course, if you want, you can put 1 here if you want to. Otherwise, it's 1 by default anyway. Print A. Print A. Okay, print A. Then we now have AB to be B A plus B. Okay, because we want to print A, which means we want to include that 0. Because if we don't, we want to print it first before we now do this, perform this action. Okay, A to be B and B. Because if we have it this way, first, before we print A, then it will include the 0. You see what? Let's see what I'm talking about. A and equal to. Let's put this in a vertical So if we let's put it in a vertical line, in a horizontal line, I mean. So you see this, if we had it first, if we did this line of code first, before we print A, because here, the initialization is A is 0, B is 1. But when we do this here, this follows this step by step, top-down approach. So for value in range from 0 up to n, because that's what this means, up to n. And if you like, you don't need to put 1 here. You don't need to. Okay, but we can leave it like that. A will now be B, which means that A that is 0 before will now be B, and B is 1. So that's why it's 1. That's why this first one is 1. See that? So if we want to have that 0, we are going to cut this here, and we put this line of code here. And let's run this. Put it. Yay! Yeah! Thank you, Jesus Christ. This works now. This works now. Thank God. This works now. So I'm just gonna copy this, and I will come here and I will paste it. For loop. I like for loops, honestly. I like for loops. Oh wow. Oh, this end line. Hi. They want it as vertical. I put it as horizontal so that I can see the whole thing, so I wouldn't have to be scrolling down here. Especially, I'm using this on a laptop. I'm recording this video on a laptop, so I don't want to keep scrolling. I want to make sure I see all the results. As you can see here, this is all the results here for n equal to 8, 9 values. So that's why I put that, because I'm doing this on a laptop. So I need to see the whole thing. And if you want more space, you can, if you space this more, if you want more space, you can. Gives you more space. You just increase the space, All right, come here, check it. Yo, thank God it works, okay? All right, let's go ahead and copy this. I'm going to copy this, question 8. Copy the whole thing. Cut it. Okay. The break statement, you can read this up. Now, break is, you see, I think I used break earlier on in this video. I used break when it was running, when the loop was running and I had to stop it. So you can use break to stop the code. But it says here, however, the break statement in the loop, the break statement should never need to be used. You don't need to use it. You can still write any program that seems to require a break statement can be rewritten to work equally well without it. And that's true. Let's run this code. Yeah, that's true. I mean, it breaks when I is 7. I is equal to 7. But you really don't need to use that. And also the continue statement means you skip it. If I divided by 2 gives you a remainder of 1, so which means it's not an even number. If it gives you a remainder of 1, that means it's an odd number. So for all the odd numbers, skip it. That's why you say continue, which means skip all the odd numbers and print out just the even numbers. Okay, print only the even numbers. So, okay, thank God this is done. So, I will save this, and if you want this, you can just send me an email. Okay. Thank you so much for listening to this video session. If you have any questions, please feel free to ask. And you have a great day.